If we could all give a very warm welcome as I introduce Team Moments. Thank you.
Hello everybody, thank you very much for coming along today. We're really excited to be able to present to you our application which we spent 8 days working on, which is called Moments. So, next slide please. So my name's Dominic and I'm joined by Dan, Mara, Kia, Alex and Andy. So Moments is a digital picture frame that allows you to share your favorite moments with friends and family. And you can customize the experience by controlling what images are displayed on the picture frame through our mobile application. So now I'm going to hand over to Humera, who's going to give explanation.
Thank you. The frame can be used by anyone who you want to share your favorite moments with, be it in your own home or on the mantelpiece at your grand's. As long as you have an internet connection, wherever you are in the world, you can use the app to upload pictures and display them on the frame. Alex will now give you a live demo of our app.
So I'm just casting that app over to the television so I can show you what's happening live on my phone. This is our landing page for the app. It's just a quick carousel that gives you a little bit of information about how to use it. So welcome to Moments. You can upload photos from your phone straight onto the secure cloud storage, which we've done using AWS. Secure facial recognition on the frame then allows you to switch over your photos to enjoy. Just hit done and we'll get straight into the app. So I have already got an account registered, so I'm just going to sign in using my Apple Face ID. We will get to our own Face ID a little bit later on. But here we are, that's recognised that that is me. I've got a couple of photos on my account already just to demonstrate with, but I will go ahead and add a couple more. So we'll just go into my camera roll and choose a photo, so we'll go for that next one. We can also take a live photo as well, maybe a nice Leeds skyline. So we'll pop those on there like that, hit upload photos, and we get a nice little animation just dancing around until the photos have gone up. Check back into the Albums tab, and those photos have arrived. Now, if I can get your attention to go to the frame, if I hit the Frame My Moments button, we should get a live refresh, and those photos will cast over onto there. Might take a minute for Amazon to wake up. Hopefully we can get those onto there. There we go. Sometimes the AWS servers can be a little bit slow. We've not used them for a while, but there we go. I'm going to pass you over to Andy, who's going to take you through signing in as a new user.
Thanks, Alex. Okay, so exciting times. I'm going to be the first new user. So I'm going to hit register first. I'm going to put my username in. So that's Andy. Put my password in, which I'm not going to tell you. Then I'm going to put my email in. Now this uses AWS Cognito for its authentication, and I need to send off a little request, and it's telling me that I need to check my emails. So if Alex would do me the pleasure.
The email that's come through, we've got 310543. So this is just to authenticate using Amazon. This should make us a new user in the user pool, and there we go.
Cool, thanks. Right, as you can see, it likes me. I am now the new user. So first thing you need to do when you get a new account is to take a reference photo, because this will help with the facial recognition later on. It's nice. Oh. It was a heavy night last night. So more dancing dinosaur time. We'll let it do its thing. So now I'm going to go over to my album. As you can see, no photos in there at the moment because I'm a new user. So let's change that. I'm going to go to my camera roll. Pick something scenic. I do like this one. And let's go for another one as well. So, lovely. Those photos are now there. But instead of hitting Frame My Moments, oops, no. I'm going to take the photos again, sorry. And actually upload them this time, because that's how the app works. More dancing dinosaurs. Dance, dinosaur, dance. There we go. Now I have photos in my album, but I'm not going to hit the frame. I'm going to use the facial recognition. So I'm going to pass it over to Dom to explain what I'm doing.
So Andy is now going to activate the facial recognition by touching the capacitive touch switch on the picture frame. The Pi will recognize his face through a hard detection face cascade model. And once it's verified, it will then trigger a AWS Rekognition to verify his face with the reference photo that he's taken, and then it switch over the photos. So now I'm going to pass over to Kia.
Yeah, so I'm going to talk a bit about the tech stack, which we and the fact for you here. As you can see, 76% of the tech we used was brand new to us. We'd never used it before. Yeah, so I'm going to talk about the front-end tech stack. So that's in the bottom left-hand corner for you guys there. So the app is cross-platform. It works on both iOS and Android. We used React Native and AWS Amplify to build the app, and we did AWS Cognito for authentication. The app also runs on Expo.
We decided to develop the app using React Native, mainly because we had some experience with React.js throughout the course for front-end development. We also knew we were going to want to develop for both Android and iOS, and React Native was capable of compiling down into both of those native applications. We did Flutter and worked with some dark code to see about using that instead, but thought our tech stack was already a little bit ambitious, having the Python language on the back end as well. So we just wanted to make sure we could really nail the front-end application for user experience. We used Expo to develop the app. We chose this over Xcode and Android Studios just so we could run those live on the phones while we developed. It meant we could deal with any bugs that came up for having both of those running at the same time. We also knew we were going to want to have the secure user login because obviously photos and personal reference photos and that kind of thing is quite secure information. So we wanted to make sure that couldn't be accessed by any other users. We knew AWS Cognito would be able to deliver that for us and would also tie in quite nicely with the rest of our tech stack. All that meant was we had to initiate our React Native project through the Amplify command line to give us access to those packages that we could use.
Yeah, so although the app was a success overall, we did face a number of challenges along the way with all that new tech. One of the main issues we had was with React navigation in React Native. We found it to be not very flexible. We planned our app out to start with, but as we increased and expanded the functionality, it became more and more difficult to keep track of this. We ended up using React hooks, which was something we'd not done before, and they took some getting used to it. It did slow us down quite a bit. Another issue we had was with AWS Cognito. That was mainly surrounding the styling. So when we first introduced it, it was effective, it was functional, but it impinged quite severely on the overall look of our app, encroached on our app. It didn't look very nice, so we ended up creating our own form, and it looks much nicer as you can see it integrated in the app now. Now I'm going to hand over to Andy on backend to talk about the tech stack there.
Thanks, Kia. Okay, this is the good part. So the back end, we have two servers. So the first server handles the image upload, it handles the URI images, and the second server handles the database requests. So both servers were built using Express, and they also use multer and multer S3. So briefly, multer handles multi-part form data, and the multer S3 sends the image off with the AWS credentials. Now, both servers were built using a test development methodology or practice, and we used Jest and Supertest as our frameworks. And this particular server was hosted on Heroku. Right, I'll pass you over to Hamara, explain the second one.
Thank you. The second server is receiving the URL of where the image is stored in the cloud and communicating with the database. So we went with a DynamoDB database, which is non-relational, and each user is stored as a unique item in a table. Our code follows the MVC architectural pattern, so we permissified both the multer functionality and the database requests so that we could implement thorough error handling and testing. We use AWS DynamoDB document client to simplify the CRUD operations. And we used a Lambda function which listens to DynamoDB streams and triggers when an image is deleted from the database so that it's also deleted from the bucket. And finally, we deployed this through Claudia onto AWS Lambda and API Gateway. A challenge we faced was that initially both pieces of functionality were on one server, and what we found was that we couldn't send an image from the app to the bucket. So we solved this by separating it into two servers and hosting one on Heroku, and that solved the issue. Back to Andy.
Okay, yes, we had another interesting challenge in one of our AWS Lambda functions, this particular Lambda function being triggered by Dynamo streams. And it basically, if it came across an error whilst it was looping through, it would continually loop over the same one. We came to the conclusion we had to promissify the whole function and resolve it when it hit an error so that it'd move on to the next event. And it was happy days after that. So yes, I'll pass this on to Dan, and he'll explain a bit more about the tech.
Thanks, Andy. Back onto the actual hardware that we used a Raspberry Pi to power the frame, and specifically the tech that we used with the Raspberry Pi was Python, Bot03 to contact the DynamoDB, and OpenCV with AWS Rekognition for the actual facial recognition part. So the slideshow half of the functionality, in a sense, works that the Pi constantly checks the database using Bot03 to see if any new URLs are present for any specific user, or vice versa, deleted. It then downloads the list of URLs, compares it with a locally saved one, and therefore decides whether any more photos need to be added or deleted. In the end, it all gets displayed in a slideshow format using FEH, which is a terminal-controlled image viewer.
And with the face recognition, that runs simultaneously alongside the slideshow functionality as well. So as Andy demonstrated earlier, that once the capacitive touch switch is activated, the PiCamera is turned on, and using OpenCV and a Haarcascade facial detection model, it captures Andy's face, and then it uploads it to the S3 bucket, and AWS Rekognition is then invoked on that bucket, and it will check the captured image with the reference photo. And once the face is verified, it then switches the active user on DynamoDB, and then it will display their personal photos.
So one of the bigger challenges we had to overcome was actually using Python, because me and Dom have very limited, if not at all, any experience with Python, and there's a lot of things to consider, like virtual environments and where you're installing all the packages. So after fiddling around with that a lot, we sort of got it to work together quite nicely, and it's all happy news with that.
Yep, and trying to run two programs concurrently as well was a bit of a challenge. We had a bit of difficulty trying to figure out the logic behind that as well. There was plenty of errors that occurred, and trying to debug errors when two programs are running concurrently was very difficult. There was lots of brainstorming involved in that and trying to figure out what was going on, but we did eventually get there in the end. And on top of all that as well, we also had the hardware to contend with. It was the first time we've ever used a Raspberry Pi. We had to figure out a way to connect a capacitive touch switch, have a camera module, in addition to having LED lights on there as well, in addition to also figuring out the facial detection feature also. So we did that. We did a lot of documentation reading, plenty of Googling, plenty of spiking as well, and trying to piece together those things individually. And then we eventually came up with a complete package which actually works, which is great. Just a little bit bonus image down here. You can see the facial detection from the Raspberry Pi, which is run locally there, uploading to SV Bucket. I'm going to pass you over to Homera now.
Thanks. So throughout our project, we followed Agile-inspired practices. So we had morning and end of day stand-ups where we discussed what we'd gone through during the day, if we had any issues, anything we wanted to discuss. We also had, when we reached the minimum viable product, we sort of had a sit down where we each pulled up our code and went through it line by line so that every member of the team knew what was going on. We used Trello for our Kanban board. We pair programmed for increased efficiency. And we used Git version control for the first time in a big group. Over to Kia.
Thank you. So although the app was a success overall, it was quite an ambitious project, and there were some ideas we didn't quite have time to implement. We did all this in 8 days. The first thing was the social media APIs. So we would have liked to contact the Instagram API, was the idea. We didn't manage to do this because it takes 5 days to have a request to Instagram approved, and we just didn't have time to do that.
We also thought it would be quite nice to add more functionality into the app, so more of a direct link between that and the frame in terms of which photos we're showing, as opposed to all of your photos, potentially having user groups so people from families could share photos into one pool, also to have things like speed of the slideshow controlled from the app as well.
Much. So from a back-end perspective, it would be really great if we could move more of the functionality up to AWS, specifically Lambda functions. One example of this would be if we're uploading an image to our S3 bucket, we'd like to trigger an event which would also automatically insert the data into the database. At the moment, this is like a two-step process. So that would be something we could do. Hand you over to Dan now.
Thanks again, Andy. One thing that we did consider for the Pi was specifically to run all the scripts on boot. We couldn't quite manage that, but that would be the next logical step for this project to take, because as soon as you plug it into a socket, it will do its thing, and there's no manual sort of inputs required.
Another thing we'd also like to have a look at is improving the efficiency of the image downloads. At the moment, the Pi is cycling through every 5 seconds and contacting the database. One thing we did want to have a look at as well is using DynamoDB streams or using WebSockets to actually push that information directly to the Pi. Right, thank you very much for your attention. If you have any questions,